sounds scary for something that is relatively easy to work with. When you're working with a recursive rule, basically what you're looking at being able to do is how can you relate each number within a sequence to the number prior to it. Okay? So if you think about it, we have what's called explicit rules. Explicit rules are ones that I would call like your generics. These are your generic rules. Okay? Your generic rule for a sequence for arithmetic is your first term times the quantity n minus 1 times the difference. Your explicit or your generic rule for a geometric was the first term times the rate to the n minus 1. Well, when you're dealing with a recursive rule, recursive rules relate terms. I'll use their definition here. They relate the terms to the one before it, the preceding term. If you want to think about it that way, it shows how the terms are related to the one before it. Okay, how it works with preceding terms. That's what a recursive looks like. It sounds horribly scary for something that works out very easy. Okay? We can write recursive rules for both arithmetic and we can write them for geometric for the sequences. And it, like I said, it's really easy to do. All right? So recursive rule gives you the beginning term. So you have to always know what your a sub 1 is for a recursive rule. And then you're going to write it in terms of a sub n, the term before it. So if it's going to be the term before it, and you're looking at the fifth term, what would be the term before the fifth term? Fourth term. What did you do? Exactly. You subtracted 1. So you're, instead of writing the rule out in terms of a sub n anymore, we're going to write out the rule in terms of a sub n minus 1. We're going to write it about the term preceding it. So you have to know what your first term is in order to do this, okay? Once again, this is really scary looking for a very simple task. All right, I got a couple of examples of both arithmetic and geometric, and then we'll go from there. All right? So let's look at that example. Whoa, wait. Sorry.
Wait, so when you...
I'm just saying that you must know the first term in order to write a recursive rule. That's all I'm saying.
So when it show, when you're doing it like in there, when you do the minus 1 for a, and you also do that.
You'll see in a second. You'll see how very simple this is in 1 second, okay? Yeah, the a. This will be the recursive rule right here. This is how it's going to look. It's going to equal something, all right? And it's going to be having to deal with this. All right? All right. So let's look at this arithmetic sequence. And what I'm going to do is we're going to write out what's called the explicit rule. Remember, I always called it the generic, so I'm going to try and remember to keep calling it the explicit rule. And the explicit rule is your normal term. And then I'm going to show you how you rewrite that in terms of the recursive. How each term within that sequence is related to the one preceding it. Okay? So it's arithmetic. Which one of these 5 are we using?
Top left.
Top left, very good. So just like we've done before, this is kind of the reason why I was telling you guys to write your rules for the problems. You start to embed it in your brain of what each one of them looks like. So the explicit rule for an arithmetic sequence is your a sub n is your first term plus the n minus 1 times your difference. We did this in 11.2. You guys flew right through it. Distributive property, combined like terms. We know that 4 plus n minus 1 times 3. When I do that, what is my explicit rule then? 3n plus 1. So when you're starting with terms in this sequence, we know that the first term is going to be what? 4. So the first term was 4. What was the second term?
That would be 7, yeah.
And then what?
11,
Wait.
10.
I'm sitting here thinking, wait a second, it's just adding 3. I don't know why it's so hard.
No, it's
Now it's 13.
Well, 13 or 16.
Does everybody agree that's what that sequence will look like?
Yeah.
Okay. So each term is related to the term before it by doing what? Right. So each time we do this, we're adding 3 to the previous term. So when you set this up then to write out a rule for the recursive, I'm going to look at it in terms of the prior term. When we look at the prior term, there's my recursive. Okay. I have to state what my first term is going to be. So as soon as you start to write out what your recursive is, right below that, your first term is 4. Does that make sense? Whether you wind up with a geometric or you wind up with an arithmetic sequence with recursive, you always, always, always want to write it up in terms of that to start with. Okay? What's that?
I was saying, so it's always a minus 1, or is that just uses?
Yes, it's always going to be the a, the n minus 1. So the recursive part, should I put this in the wrong spot here? To the term before that, when you relate to the next term, what did you add to each one of them? 3. I put the equals in the wrong spot. Okay. It's been a long time since I had to write recursive, to be honest with you. This is one of those new topics that we're talking about this year that we haven't done. Well, I've been teaching for 9 years. I've been teaching Algebra 2 for 7 years, and I've never once taught recursive. You didn't know it, but now government, the government says you need to know this.
So we can do it here?
Exactly.
Probably one of the third thing was, you want me to do that one here?
A little bit. There's a little bit. So here's where things get a little bit garbled. The recursive rule still uses it in terms of relations of the explicit. They still use a sub n. The only difference here is that the recursive rule, what is different? What's the only thing that you have to put in?
A and 1?
The minus 1 to the
For the first term.
Where's that plus 3?
What's the difference?
there's no
Plus
It's plus 3.
yeah,
If the difference was a negative 6, what would you write? Minus 6. It's that.
Is this supposed to be like A and minus 1 plus D, or is it always going to be 3?
It's always going to be plus d. It's always, this d value is always going to go there.
Okay.
This is always how these things start. This is the only chunk that changes.
So we're done now?
Yeah.
Wait, why is
So you
Wait,
just
that's the
put it
recursive rule?
in, you just put the difference
We
in?
don't have to solve for it?
Nothing.
Alright.
I know. And I know. And that's now. Look what happens when you do geometric.
But then what's the point of knowing A1 if you don't actually
Yeah.
need it?
It's a different because you don't know where to start.
Actually.
See what I'm saying?
No.
You don't know what your first term is going to be. In this case, your first term winds up being at 4. I'll show you how this works because sometimes you're not given first term. Sometimes you're given the sequence. You got to figure out first term to go there.
Wait, so why don't you just write plus 2?
I'll take it.
Minus 1, like that. A and.
There is no
A and
Because it's always talking about the term before it. Okay. Let me show you this. This is arithmetic. Take a look at this. I'm going to throw it a little bit different here. This is a little bit more of the complex style. Same basic idea. You have two terms in the arithmetic sequence. We've written these rules before. It's going to ask us to write out the explicit, which is your generic. We're going to write out the recursive, and we're also going to figure, oh, that's all it is. And then find the whatever the 24th term is. So here we're going to do three things. Write the explicit rule, recursive rule, and what's the 24th term.
Okay.
In order to do that, you know that the 13th term is something, you know that the 38th term is something else. When you had two different terms, how many times did you write out the generic formula?
Right.
And then what did you do?
So we did the formula and systems of equations.
Yep, you do a very quick, simple system of equation.
I know, please.
Oops. So the 13th term is 1181. That's my first term plus 13 minus 1 times whatever my difference is. So it's 1181. It's first term plus 12. Direct substitution, combine like terms, and go. Everybody okay with that?
Yeah.
Do the same thing with the 38. 38th term is 3681. That's my first term plus 38 minus 1 times my difference. I get first term plus 37 times d is 3681. Systems of equations, you'll obviously, I'm hoping you'll notice you want to eliminate your first term. Do we agree?
Yeah.
So I'm going to take the equation written in red and subtract the equation written in blue. All right? What's your D?
100.
100. Everybody okay with that? I don't have, you could use substitution if you want. The reason I'm not using substitution is if I line these two up, I can eliminate the first term right away. It's just quick, it's a quicker method of doing it. There's nothing wrong with substitution if you want to go that route. You'll still get the same answer, you'll just take a little bit more time. Okay? So you get 100 for your difference.
Yeah.
Now, to solve for your first term, can I just substitute there? So that means that my first term is going to wind up being 1181 minus 1200. Is that okay if I just say it like that?
Yeah.
You get what? Negative, what's it, 19? All right. So negative 19 gets me my first term. All we did there is we just solved a very simple systems of equation. The numbers looked like they were going to be god-awful, but it worked out to be fairly clean. We okay on that?
Yeah.
So do I have enough information now to write out my explicit rule?
Yeah.
Yeah. I've got my explicit rule, which is my generic term. I know that a sub n is my first term plus n minus 1 times my difference of 100. That's the explicit rule. That's the generic when we combine it, put them all together. Distributing and combining like terms, we get a sub n is 100 n minus, was it 119? There's your generic rule. We okay on that? Explicit. Yep, explicit generic rule. Now, after that, I'm going to figure out what the 24th term is because it said, well, we'll do this last. The recursive now. Recursive. We know that the recursive rule relates to an n minus 1. What was the difference in this problem?
Plus 100.
100. So the recursive rule is your a sub n equals, what is that going to have to equal?
A minus 7.
A to the n minus 1. And then what do I do to that?
Plus
Plus 100.
Plus 100. And what's your first term?
Negative 119, negative 19.
And that's how you write out recursive. See how easy it is how they interrelate to one another?
Yep.
All you're doing with recursive rule for arithmetic is tacking on your differences and writing down what your first term is. That came, remember in the very first part when we wrote out the explicit, we had to figure out what our first term was?
Yeah, I know that, but what's the recursive?
It's both parts put together. Because this recursive rule is dealing with this specific sequence. Yes? It's a subscript.
So funny.
You're right, I did say to the n minus 1, didn't I? Sorry. He picked up, I really did say to the n minus 1, I meant to be subscript n minus 1. I apologize. Now, what's different with the recursive, yeah, this is a very simple thing. It's just whatever the term was before add 100, but you just didn't know where you started within the sequence. That's why they always write down what the first term is. Okay? What's that?
Yeah.
I really didn't hear you. You kind of moved a little bit. Oh, the 24th term. Yes, 24th term. That's very easy. Thank you. I'm old. I don't hear stuff. Too many concepts. You guys can probably figure that out. I don't have to go through that one, right? 24th term? 24 times 100. 2400. Subtract 119. 2281. Okay. Now, let me show you what it looks like geometrically. Yeah, yes. Rarely. What sticks is that some of the projects I used to do, we don't have time for anymore.
Well, I think if they're actually credit, we can make fun.
All right, take a look at this one. In this case, we have a geometric sequence. You'll also see that right, the geometric ones for recursive are also very, very easy to do. I'm going to start with, I have given to me my first term of 3, and I know my rate is 0.1. So I'm going to start with writing out my explicit rule. The explicit rule means I'm going to my generic. It's going to be first term times my rate to the n minus 1. So when I start with this one, I just have to fill in the blanks. First term is 3. My rate is 0.1 to the n minus 1. And there's my generic rule. Okay? Now when I go to, that's the explicit. When I go to the recursive then, when I did recursive with arithmetic, how did we start that? What did we always, well, let me ask you this. What did we always have to have?
The A1.
A1.
You always have to have your first term. Okay. We'll have this, and we'll have our first term. Our first term, excuse me, kids are starting to cough at home. Everybody's, it's that time of year, right? There's a, I don't know if it's up here yet, but I know it's downstate. I wouldn't be surprised if it shows up here anyway. There's some really nasty, really bad upper respiratory virus that's really weird.
Yeah, that's.
It's not Ebola. It is not Ebola. All right. Now, what's up, Hummer?
I'm the observe and meet with my favorite teacher.
Shut up, Hummer.
I'm just standing in the back.
When you work through your recursive rule, the only thing that changes here is that you still have to use the same rate. What's our rate? 0.1. So it's going to be 0.1 times the previous term. That's it.
Wait, why is
It's cleaner written instead of having the 8 to the n, a sub n minus 1 times 0.1, it's just cleaner. Bless you. It's just cleaner to write it up in front, that's all.
So the recursive rule is AN equals the rate times AN.
Every time.
Okay.
And then the only other part you have to remember to put in there is whatever your first term is. That's it.
So the for geometric is multiplication and for the that arithmetic
Yep.
distribution.
Yep, that's it. It's that plain and simple. Now, what changes here is, remember when we did geometric stuff given two terms? When you do geometric given two terms, we do that stuff we did yesterday where you have to sometimes do a systems of equations again to solve for your first term. So that's like the little twist that I'll give you guys. It's not going to be, oh, here's your first term right away. I'm going to make you work a little bit for it, which isn't so bad. Why? Why not? Aaron. So here, oops. Here we have the second term, and I have the third term. Now, we could go through the whole rigmarole of figuring out by doing a systems of equation by writing it out twice. Do you agree?
Yes.
But notice, we're going from the second to third term.
Yeah.
Did you figure out your rate? What's your rate?
Negative 2.
Your rate's -2, isn't it?
Yeah.
Everybody see that? It's still,
So A1 will be
how do you figure out your first term is then?
5 by
It's -4. Everybody see that?
Yeah.
Now, is it okay that you walk through it to figure it out in your head, or did you want to write it out the long way? Sometimes it's that easy where you're given consecutive terms. If you're given consecutive terms, do it in your head. It's quicker. All right? So now you know what your rate is, you know what your first term is, your explicit rule. First term times rate to the n minus 1. Well, it's -4 times -2 to the n minus 1. That's explicit. When I go to the right recursive then, what's my rate? -2. So my recursive is going to be a sub n is,
-2 times A sub.
that's it. And what's the only other thing you have to write down for recursive?
A1.
Like I said, it looks a lot more difficult than it needs to be. Question time. All right, begin.
Wait, did we find the common ratio?
You had to find the common ratio to be able to write that out. How school? Blow stuff up.
Now we're crashing course.
Now, what I've done here on this is I've kind of created a whole big do. What I'd like you to do on this little packet here is I'd like you to start with 31. I'd like you to go 31 to 40. This is 10 of them. All right? And if you read them through, there are instructions. They mix up of what you have to do. They tell you what you have to do to do the recursive stuff. They might have to write up a formula explicitly, find this, find that. But this is good review as far as all the different methods of working back and forth of writing the rules. And then get into the recursive. The answers are on the very back, so you'll be able to check your stuff, okay? Is that fair? 10 of them? And we'll go into the rest of the stuff, and we'll do some more system stuff tomorrow with series and everything, okay?
I'll come back to our folks. I gotta get close and watch that.
So